Hi students, this is Walter back again with Mathematics Senior 6. We are still in the same unity, Unit 1 of complex numbers. Ladies and gentlemen, if you have followed me in my last lesson, I talked about the division of two complex numbers in the polar form. We are still on those operations in polar form, and today I will talk about power in polar form. We can also find the power of a complex number in the polar form. So ladies and gentlemen, what we do always need is to first put in the polar form the complex number, and then after putting in the polar form, we can find each and every operation about it. So ladies and gentlemen, we shall consider here a complex number z in the polar form, which is equal to r cosine theta plus I sine theta, ladies and gentlemen. Then if I'm asked to find now the power, it means I will find that z power n will be given by what? If n is a power, I will now get it is r cos theta plus I sin theta, all of this power n. And then the formula will be z power n, which will equal to what? To be equal to r power n cosine n theta plus I sin n theta, ladies and gentlemen. And you will see what we observe here is that when we are looking for the power of a complex number in polar form, we just find the modulus. We take now the modulus of the complex number z power n, and to find the argument, we just multiply the argument by n until it's solved. Here I will give you an example. If you have now to find, for example, 1 minus I power for example 10, power 10, how are we going to get it? So ladies and gentlemen, you can see that if we are to expand this, it will take a long time. It will take a time. And now what do we do? What we do here, if we are to find this power now, we first put 1 minus I in the polar form, and after putting it in the polar form, we express the power, and we use this formula to find the power, to find 1 minus I power 10. And it will be very easier and quick. You will see it when we are doing it. We see now z equals to 1 minus I. Putting it in the polar form, we need to find the modulus of z, which is equal to r, and this is square root of 1 squared plus 1 squared, and this is the square root of 2, ladies and gentlemen. And now, if I'm to find the argument, you are used to this. We are going to see that x equals to 1, and this is positive. And now, if x is positive, we remember that we don't look for the condition for y, but we immediately say that the argument of z, and it's the angle theta, immediately say that it is equal to tan inverse of y which is equal to negative 1 over x, which is equal to 1. And here, ladies and gentlemen, it's like they can ask you which angle that its tangent is equal to negative 1, and that angle is none other than negative pi over 4, ladies and gentlemen. After finding now the argument, we shall see that the complex number z can be written as this in the polar form. It's square root of 2 factor cosine negative pi over 4, which will always be cosine pi over 4 because cosine function is an even function, minus now for sine. Remember that sine is an odd function. This will now be minus I sin pi over 4. Why do we have negative here? We have negative because the argument is negative, and sine is an odd function, which will make it here negative. So later on we have z now in the polar form, and after finding that, you can now find z. We shall find now z power 10. Then this is what we have as 1 minus I power 10, ladies and gentlemen. And this will be what? don't go far. Immediately, as the formula say, take the modulus power n, and then here I will have now square root of 2 power 10, then cis. For the argument, for the argument, what we do, we multiply the argument by n. So it is cis, n is 10 times pi, negative pi over 4 here. And ladies and gentlemen, if we are multiplying this now, later on we shall see that this was not, n is 10, so we have 10 here, sorry. And now we multiply n by the argument to get the argument of the power. So here, square root of 2 power 10, we shall have now that it is equal to 2 power 5. Why is it equal to 2 power 5? Because here the index is 2. If we divide 10 by 2, we get 5. So cis, and then here we simplify here, ladies and gentlemen, and we shall remain by 5 minus 5 pi over 2. This is our solution. Negative 5 pi over 2 will be the argument, and 2 power 5 will be the modulus of the new complex number in power. So here we have found the power of this complex number, which is equal to 1 minus I power 10, and then this will be equal to 2i cis negative 5 pi over 2, ladies and gentlemen. So after this now, we shall see a theorem which is called De Moivre's theorem, which we get from the power. Let's see it. So ladies and gentlemen, from the power of a complex number in polar form, we can deduce the De Moivre's theorem. This theorem, how do we get it? We have the power of a complex number in polar form. So we have that z power n equals to r power n cosine n theta plus I sine n theta, ladies and gentlemen. So this is the power of any complex number z in the polar form. Now, how do we find the De Moivre's formula? The formula or the theorem of De Moivre, how do we find it? It is when n equals to 1 in this formula. In this formula z power n, if n equals to 1, what do we get? If n equals to 1, we get now cosine n theta plus, I said now, let us have this. It will be cosine theta plus I sine theta. So if now r is 1, we get the De Moivre's theorem. If r equals to 1, of course here there is no r. It will be 1 power n, and it will always be 1, obviously. So if we are now finding this power n, we shall get that this will be equal to cosine n theta plus I sine n theta. This is what we call the De Moivre's theorem, and we shall see where we use it from. And here we must know that n must be what? Must be a positive. N must be a positive or negative integer. Maybe a negative or a positive integer, and also it can also be a fraction. The power can also be a fraction here for n. N can be any integer, either positive or negative, or it can be also a fraction. So in this De Moivre's formula, I will show you where we shall use it later on, especially in the linearization that we shall see here of a lot of trigonometric expressions that we shall use to linearize it. So when we reach where we shall need it, I will call it back, but by here we can just mention it. So later on now, ladies and gentlemen, we have seen here how we find the power of a complex number in the polar form, and I have shown you a small example, and from that we have got the De Moivre's theorem, which is here, that we shall use later on in linearization of trigonometric expressions. So ladies and gentlemen, I cannot leave you without a small homework that you will do to see whether you have understood how to do any operation about power in the polar form, and then you will see how you will be successful after. So ladies and gentlemen, here is your homework. I am asking you to express z, which is equal to 1 minus I square root of 3 power 4 over 1 plus I power 3 in the polar form. If you can see it clearly, it will be very tough or hard to you to just expand this. But if you use the formula we have seen on how you put this in the polar form and this in the polar form, and then you use the power formula that you have seen later on, you will be computing this easily, and after you find the ratio of the two expressions using also the formula we have seen on how to find the division of two complex numbers in the polar form. And ladies and gentlemen, if you get this answer, you will be very right and you should congratulate yourself. The answer is square root of 4 square roots of 2 6 negative pi over 12, ladies and gentlemen. If you reach on this solution, you'll be very right and you should congratulate yourself that you have done a great job. Ladies and gentlemen, you know they have been passing a lot of videos here and a lot of lessons, and maybe you have missed one of the lessons that we have passed here. So you will visit our website, which is www.ubumenyi.net, or you can go back to our YouTube channel, which is Ikaramu TV, and then you can there see a lot of video that we have done so far. You will also remember to subscribe as well as sharing for your colleagues so that they can also learn about what you are doing here. Thank you very much to our teacher Walter, and I invite you for the next lesson, which is still going on. Thank you. God bless you. I love you.